All right, thank you. Good morning. I'm not wearing a tie, so this is intended to be, informal. If you have questions, please stop me at any time, and I can address them. As Susan mentioned, this was really supposed to be Elmer's section, and he unfortunately couldn't be here today. I was glad we canceled because of the weather forecast last time. It did come to pass. It would have been difficult for us all to be here, so I was glad we did that. But unfortunately, we've had to scramble to get everybody's topic covered. The advantage to this is that Elmer is the creator and curator, manager, and user of a clinical data warehouse that we have here. I, however, am much more of a consumer of clinical data and clinical data warehousing. So you're actually getting his slides and my perspective. So I hope that actually works out well for everybody. And also just one correction. I don't know if okay, the final thing did get, final agenda did get updated. I am not the associate dean. That would be Elmer. Okay, so just a little bit about the clinical data warehouse that exists here at UT, at least in the School of Biomedical Informatics. It's a collaborative effort. It's a joint project between MD Anderson and UT Health. They come together and collaborate for the Center for Clinical and Translational Sciences, or CCTS, and out of that there's a biomedical informatics component. Coming down the other side, that's just pure UT Health, is the School of Biomedical Informatics, and our access to the UT physicians' clinical data that they use for their operational clinical practice to take care of patients down the street. And Elmer's group is the Biomedical Informatics group, or BIG. So in conjunction with the CCTS, that's the sort of administrative unit that houses this wonderful clinical data warehouse somewhere in the cloud. And the big group has a suite of applications and services that they provide. This clinical data warehouse is just one of them. They have some other things that they do, which I'm not going to talk about. And it exists in this cloud where there's this tension and kind of back and forth between research questions and service questions. So what do we mean by that? And that's actually a really good thing. It's worked well for them. So a service question would be how many, that maybe the physicians group would come to the big group and say, how many unsigned clinical notes do we have in our enterprise EMR? And that's important because if it's not signed, we can't bill for it. So we really, and it's a compliance issue. So we really need your help in identifying those notes so that we can get it taken care of, send some email. That's an operational question. That's a service request that can be answered with this clinical data warehouse. A research question might be, how many patients do we have in our clinical enterprise with a hemoglobin A1C that's over 9, who also have congestive heart failure because we want to enroll them in a research study? That would be a research kind of question, and could be, also has a lot of value, but it's not the same sort of thing. And then there are other questions that kind of exist in between, like how many patients are there with a hemoglobin A1C over 9 so that we can give them better care? How many patients do we have whose lab results we've never viewed? So lab was ordered, and nobody ever looked at it on the way back. So that may be a research question to answer, why didn't we look at that lab? And there's also a service component for maybe we shouldn't be ordering that lab, and can we stop that practice? Let's identify those patients. So there's a back and forth between those two things that's actually quite productive. So what we're planning to talk about here is just what is clinical data warehousing. What kinds of questions can you try to answer with this data? What are the challenges? What's easy about it? What's easy to do, and what's hard to do? So what is a clinical data warehouse? So clinical data in this era starts in an electronic medical record. It didn't 30 years ago. That was all on paper. That was still a warehouse of data, but we really literally shipped it to a warehouse when we were done with it. So the electronic form of that is optimized to answer questions about a specific patient. So the context that EHRs work in is in a clinic where you're sitting down, or a hospital where you're sitting down trying to figure out what to do with the individual who's sitting in front of you. So you want to know things like, what is John Smith's weight as I'm sitting here in clinic trying to figure out how to help him lose weight or gain weight or whatever. It's the structure of the EHR from a sort of technical perspective is optimized. The schema is optimized to answer all the questions about that particular patient very quickly and very efficiently. It's focused on the individual. It's also focused on being very secure, very transactional. You know, if you make an order, you want to make sure that that order gets, that transaction is completed with high reliability. Those sorts of things. That's what EHRs are optimized for. A clinical data warehouse, on the other hand, is not intended to be used while you're sitting there looking at an individual. So there's a transformation of that data when you put it in a clinical data warehouse that optimizes it for looking at patterns across multiple patients. That's a very different sort of question. It leads to all kinds of different technical concerns as well as social and administrative concerns about how you're going to access that information. But it's very good for answering questions about a population or between patients, across different patients in a population. So some of the components that go into clinical data warehousing, the hardware and software infrastructure that you need to support it. One is I2B2. Do people know what I2B2 is? Have anybody heard of that? It's 2 I's and 2 B's in the acronym, thus I2B2. I'm probably going to mangle what it actually stands for, but the 2 I's are integration and informatics, and the 2 B's are biology to the bedside. So it's something like integrating informatics for something to from biology to the bedside. I always kind of mangle it. So it's just I2B2. It actually started at Partners in Boston. So and it's a modular kind of architecture so that you can extend it. It has some flexibility built into it, into the design of it. It has a data model that goes along with it, and then also a user interface, which I'm going to show you. That's very easy to use, which I'll show you an example of in a minute. So other components of data warehousing that are, equally important, perhaps more important than the actual hardware and software that support it, are the processes and procedures that govern it. So one aspect of this is the technical, the extract, transform, and load process, or ETL. This is where you take your data that's in an EHR that's optimized for transactional operations and for only looking at one patient, and you transform it into a different schema so that you can optimize it for looking across populations. So the timing of how frequently you conduct your ETL operation is variable. Herman for their ETL does it, I believe, once a day. So they just take all their operations data for the day and dump it over. Here we get, I think we get data extracts from UT physicians. I think once a week we do it for our data work. So that's an administrative concern, how frequently you're going to do it. And then there's the regulatory and political processes around data and data warehousing. So where's it coming from? Who has access to it? Who controls who has access to it? How are we going to keep it secure and private? How are we going to anonymize it in cases where we want de-identified data? What are all those administrative things that go around it? And to be honest with you, in my experience, that is actually a much bigger piece of work than the actual technical components of doing this. It's the processes around how it's going to be governed that's really, really difficult to manage. And then there's the data. And a key point here is that clinical data is not the same as research data. Clinical data is collected to serve the purpose that's needed when you have a patient sitting in front of you in a clinic who's been waiting an hour in the waiting room and is impatient and wants the visit to be over, also wants to spend a lot of time with you talking, not a lot of time with you typing. So that's what that data looks like. It's often rushed. It's often incomplete. It is not collected for any purpose other than to support that visit, which was to document the care that was given, at least approximately, and the recommendation going forward with that. And there's administrative concerns about like what kind of diagnosis codes get assigned and that sort of thing too, which it's very good at capturing that piece of information. But other stuff, it's not great for optimizing. So if you're trying to use your data for a research question, you have to remember that this is not research data. It was collected for a different purpose. There's a lot of information that gets captured in clinical encounters. And it's a lot of work to try to make sense of what it all means, particularly in this environment where you know it's very noisy and has a lot of error, or at least inaccuracy in it. This creates many research problems. And again, that's where the problem is. It's easy to get every blood pressure out of a clinical data warehouse for every patient that's come to your clinic in the last year. It's a much harder question to figure out what to do with that, and that's where the kind of research focus is. So the traditional view of how data is captured, I sort of alluded to this. It starts with a doctor and a patient in a clinic. Oftentimes, the documentation is done asynchronously because patients don't like it when you're interacting with the computer while you're sitting in the exam room with them. So you may see a patient and then go out of the room, or later in the day or whatever, you sort of finish that clinical encounter documentation. It's very frustrating at times as a clinician to do that, but you have to. The data gets pulled into the EHR, and then at some point there's the extract, transform, and load process that then ships it over into the clinical data warehouse. Once it's in a clinical data warehouse, there's the opportunity to bring in other sources of data and link it with things like, say, for example, a genetic database that you have. That's something that MD Anderson provides with our clinical data warehouse. And that's where the real gold is. Once you put all that information together, that's where you can do some data mining and actually try to make meaning out of all of the data that you have put all this energy to put together. So research versus administrative data in your warehouse. So the key question when you're trying to figure out what to do with this information or how accurate it is whether you're willing to accept administrative, and in most cases this is billing data, are you willing to accept that as a proxy for clinical reality? If you're asking a clinical question, will the administrative data serve as a proxy for it? Because you know that the actual clinical encounter data is very noisy, very dirty. So an example of this is you could use your clinical data warehouse to find all the patients who have breast cancer. That's the clinical question. I want all those patients. So if you're using administrative data, you could do that by saying who has been billed for a diagnosis code related to breast cancer. However, those are two very, very different things. If you're willing to accept the reality of the universe of patients that's returned when you just look for that billing code, then this really isn't a research problem. We know how to do this. That's actually a very easy database query to write. It takes resources to actually execute on that, but it's not difficult. It's not a research question in and of itself. Where you get into trouble is when the answer is no. I don't think that just using a billing code is an adequate way to search for patients with breast cancer. That's where it gets interesting. And there are many unanswered questions about how to do that. And I'll show you some data here that Elmer has done on this very question about breast cancer. There are other cases where the administrative data may work just fine. It may actually be a pretty good proxy for clinical reality. But there are lots of research questions where it's not. So this is his example of high throughput phenotyping. So this is identifying individuals with specific characteristics based on their EHR data. So the question here was how many patients with breast cancer are actually in the clinical data warehouse? And it is a surprisingly difficult question to answer. It seems like it should be very simple, intuitively simple. Why wouldn't you put that diagnosis code down for a patient? But in reality, when you compare just the billing data to an alternative data mining technique using natural language processing where you actually parse the notes, you find that the rates of detection are nowhere near 100% when you then actually manually review all of those charts, do an expert review and figure out who really did have breast cancer and who didn't. That's our gold standard here. You can see that the billing data is actually terrible at extracting those patients. And applying a natural language processing technique to it, you get much better results, but it's far from perfect as well. So that's the kind of research that is going on in this space. So I keep saying how kind of terrible and dirty clinical data is. So there's an essential process of cleaning it that has to go into it when you're doing your ETL operation. Duplicate records are a huge problem for us. I can't tell you the exact number of duplicates that exist in our clinical data warehouse. Elmer could, but it's many, many, many thousands of patients who have 2 records. And there's actually evidence to show that if you have 2 medical records, you're increasing the likelihood of that missed lab, of other sources of really relevant clinical issues happening to you as a patient. So you really don't want to have duplicate records, but it's a real problem. The other end of the spectrum there is overloaded records, where accidentally you put information about 2 patients into 1 record. So that's also not a great situation. Missing data is also a huge problem. Clinical data is not unlike perhaps a research study where you're following people at regular intervals. It's totally erratic when patients come to visit their doctor, what the timing and frequency of that is. Biomedical data has inherently got a lot of variability in it. If we took all of our blood pressures now and 1 minute from now, they would almost all be different. That is, we all know this about biomedical data. So it is inherently noisy and has a lot of just inherent variability in it. And there's multiple interacting non-random biases in the way it's collected, the way it's displayed, and that also creates problems for keeping the data clean. So again, back to this duplicate record thing, there are lots of algorithms out there for filtering it that do a pretty good job. But really, you have to sort of train the process, and Elmer has a method for doing this using a combination of manual review and some automation, and that there are consequences for having those duplicates. So this is our clinical data warehouse. UT physicians data goes into the I2B2 Hive. IDX, which is an administrative kind of piece of billing software that sits on top of our clinical data, which is stored in the EHR is Allscripts. So we have about 500,000 patients in there. So who are the consumers of this? One is the primary informatics researchers who are doing things like developing natural language processing tools to actually make meaning out of that information. There's applied informatics research. This is the high throughput phenotyping approach that I talked about. There's a lot of synergy there with the service requirements of the clinical data warehouse. And then clinical research and public health research, things like biosurveillance, drug repurposing. Is there a connection between metformin, which is a drug to treat diabetes and cancer? That was one sort of discovery that was made through these kind of big data approaches. And then service, which I already mentioned, is the unsigned note issue. And another service question that's sort of research oriented is do we have enough patients at UT that visit us with this problem for us to actually do a study? And I want that number so I can put it in my research grant. So users, informaticians who want direct access to that data, and we're able to provide that to people. Translational researchers also want some sort of intermediated access to the data. They don't want to actually write SQL queries. They need another interface for doing that, and I2B2 is one mechanism. However, there hasn't been a lot of enthusiasm when people are given access to I2B2. They tend not to actually use it that much. They sort of prefer to have the service provided for them. The most common request is for counts. So how many patients do we have so I can apply for that grant? So here's an example of what the interface, the web interface for I2B2 looks like. You just log on. It's a graphical drag and drop kind of application where you have nodes of data over there on the left, and you build a query by dropping them into the various columns. In this case, we've selected patients who are on anticoagulants, who are greater than 85 years old, who have a diagnosis of intracerebral hemorrhage or subarachnoid hemorrhage. You select, what kind of data the result of that query that you want, in this case the count, and save it. And after 20 seconds, it spits out that this particular database has 20 patients that meet that set of criteria. So what's easy to do? What's easy to pull out of I2B2? Data that are available in structured form. So billing data is ideal for that. CPT codes, demographics. It's important to realize here that data means what you want it to mean when you're the clinical researcher looking at it, and billing data does not equal clinical reality. And this can be quite useful for quality and safety questions if you can define the process or define the question very precisely and use and if administrative data is a good proxy for it. What's hard is actually validating your answer once you get it. People tend to see what they want to see to confirm their own hypotheses, and when you're dealing with multiple competing biases in your data set, that's a problem. It's hard to get at real clinical reality. Yeah. So I've drank the Kool-Aid. I still think this is this is the future. We need to get better at this. There's tremendous potential. Here's just a little hint of what you can do with a clinical data warehouse. This is retrospective, but they used a clinical data warehouse to identify patients who had a heart attack based only on their ICD-9 code, and also were getting Vioxx. And you see, what if we had intervened, in one of those first little blips there back in 2000? We could have saved millions of people's lives. So I guess I'll just conclude with this. What is it? It's a database with a process around access for it. It's an enabling technology. Ideally we can get to the point where we're doing more like that last slide, where we're actually doing surveillance of our healthcare system and learning as we go along. There are already a lot of things that we can do that are very useful with it, but there are still a lot of challenges. The social being, in my view, the probably much bigger one, the social and administrative over the technical, but there's plenty of technical challenges too. And then the last question here is the traditional role of the library, and I guess we just sort of throw this out here. We don't have time to probably discuss it, but about data curation and management, and should libraries be the ones who are actually curating this? And I will leave it at that. And I don't know if we have time for another question or not, but I think we're pretty much out of time.